In this problem, measured resistance is given 100 ohms. R is given as 100 ohms. If 7.45 grams of KCl is dissolved per liter of solution. Here they have given mass of KCl. Okay, we need the concentration. Concentration is, how do we get the concentration? Molarity of KCl solution is how much? Number of moles of KCl divided by volume of solution in liters. Okay, here they have given 1 liter only, so denominator value is 1. So number of moles only, if we calculate, it is enough. Okay, number of moles, how do we calculate? 7.45 given mass by molar mass of KCl. KCl, K atomic mass is 39. Cl is 35.5. Molar mass of KCl 39. Atomic mass. Okay. 39.1. Okay, this is 39. So 39 plus 35.5 will be what?
74.5.
0.5, 14, 74.5. Okay, அதே தான் வருது இல்லையா? So 10 times 1 by 10 means molarity is 0.1. Okay. இப்போ இங்க டைரக்டா ப்ராப்ளம்ஸ்ல நமக்கு என்ன கொடுப்பாங்க? ரெசிஸ்டன்ஸ் ஆஃப் 0.1 molar solution is this ன்னு கொடுப்பாங்க இல்லையா? அதுக்கு பதிலா இங்க மாஸ் கொடுத்திருக்காங்க. So mass வந்து given mass by molar mass, number of moles, volume of solution divided by volume of solution in liters போட்டா molarity வந்து. Molarity is 0.1 m. Okay ba? Calculate conductivity. What is the formula for conductivity? Cell constant is given. Okay, conductivity kappa is equal to cell constant by resistance. What is cell constant value? 1.25. Resistance is what? 100. Cell constant is 1.25 in conductivity is 1.25 into 10 power minus 2 ohm inverse centimeter inverse. Yeah. Molar conductivity, how to calculate? Cell constant centimeter inverse தான இருக்குதுனால kappa value centimeter inverse ல வரதுனால molar conductivity lambda m is equal to kappa into 1000 by c. What is kappa value? 1.25 into 10 power minus 2 into 1000 by, what is c value? Concentration. Concentration is what? 0.1. So this and this, when you cut, it will be 10 மட்டும்தான் இருக்கும் மிச்சம். இந்த 0.1 மேல போனா என்ன வரும்? 0.1 என்ன எழுதலாம்? 10 power minus 1 எழுதலாம். இது மேல போனா 10 ஆயிடும். So இது கட் பண்ணிட்டு மேல 10. So 100. 1.25 into 100 is 125. Okay. What is the unit of molar conductivity? Ohm inverse centimeter squared. Let a ohm inverse nu போடலாம், let a Siemens centimeter squared per mole. Yeah. So that is molar conductivity. Out of AlCl3 and NaCl, which one is more effective in causing coagulation of a negatively charged salt? When you want to coagulate a negatively charged salt, you have to look at the valency of the cation. Okay, according to Hardy-Schultz rule, for the coagulation of a negatively charged salt, valency cation with greater valency is more effective for coagulation of negatively charged salt. So when you compare the valency of Al and Na, Al has more valency. So Al 3 plus is more effective. So out of the two electrolytes, AlCl3 is more effective. What happens when a freshly prepared ferric hydroxide freshly prepared is shaken with a small quantity of shaken with water containing ferric chloride. Here it is a precipitate, and a precipitate is shaken with the water and electrolyte. We get precipitate to salt conversion happens. So this process is called peptization. Peptization occurs. And when you start with the precipitate, add dispersion medium and electrolyte, you will get a colloid. Peptization occurs and we get a colloidal solution of ferric hydroxide. So we represent the colloid by, when you add ferric hydroxide, water is in excess, no? See, water contains OH minus ion, which is common with ferric hydroxide. Ferric chloride contains Fe3 plus ion, common with ferric hydroxide. So this is present in small quantity, this is present in large quantity. That means OH minus ion gets absorbed over the precipitate. So we represent it as bar OH minus. So we'll get a negatively charged salt. Negatively charged salt of this one, which is represented like this, is got as OH minus present in excess in the dispersion medium gets absorbed on the precipitate. So whichever charge is present in excess, common with the precipitate, that gets absorbed, giving rise to whichever gets absorbed over the precipitate, that will decide the charge on the salt. Activity and selectivity we don't have. Limiting molar conductivities of NH4Cl, NaOH, NaCl are given respectively. So this respective values only you have to take. For NH4Cl it is this, for NaOH it is this, for NaCl it is this. Calculate the limiting molar conductivity of NH4OH. So we have to take the molar conductivity of the electrolyte containing cation of the required electrolyte, which is it, this one. And to that you have to add the electrolyte lambda naught m of value of the electrolyte containing anion of the required electrolyte. This and this added minus new ion, what did we add? Na here and Cl here. That containing electrolyte containing those two ions, lambda naught, we have to subtract from these two. So lambda naught m of NH4OH is equal to lambda naught m of the cation part containing electrolyte NO, அது எழுதிக்கோ first. Minus anion part containing electrolyte NO, அதை எழுதிக்கோ first. Sorry, plus. ரெண்டையும் add பண்ணிக்கணும். Minus இந்த புதுசா என்ன, இதை தவிர புதுசா இங்க என்ன ஆட் பண்ணிருக்கோம்? Cl. இதை தவிர புதுசா இங்க என்ன ஆட் பண்ணிருக்கோம்? Na. இது ரெண்டும் இருக்கிற electrolyte என்ன? This one. That value is subtract. Minus lambda naught m of NaCl. What do you get? Add these two. 129.8 plus 217.4. You add, you get 12, 17, 4, 3. Minus this value. 108.9. So 3, 8, 3, 238.3. What do you get? Siemens centimeter squared. Limiting molar conductivity கண்டுபிடிச்சாச்சு. Lambda naught m of the required electrolyte we have found out. What for NH4OH we have found. Calculate the degree of dissociation. Degree of dissociation means alpha we need. If molar conductivity of 10 power minus 2 molar solution of NH4OH. This value is lambda m value. Lambda naught m we know. Lambda naught m just calculated. Lambda m is given in the question. Sometimes they won't give lambda m value. They will give you kappa value. Using kappa, you have to get lambda m for this particular concentration. Molar conductivity will be different for different concentration. But limiting value alone, limiting molar conductivity alone will be a constant value. So lambda m by lambda naught m is alpha. So what is lambda m? 9.33. What is lambda naught m? 238.3. You divide, what do you get? 9.33 divided by 238.3. 0.039 is coming. Letter 0.0392 is the alpha value. Alpha is nothing but degree of dissociation. Okay. This is not there. And sometimes if they ask dissociation constant, the degree of dissociation alone is asked. So you'll stop with alpha. When they ask dissociation constant K, what we'll do? We have to go one more step. Alpha squared C by 1 minus alpha. We have to calculate. Okay. Alpha squared is what? 0.0392 into whole square. Into C value is concentration. 10 power minus 2 they have given, no? Into 10 power minus 2 divided by 1 minus this value. This will come as 0.04. 1 minus 0.04 and 0.96 will come. Put 0.96 down. Divide this, get the dissociation constant for the electrolyte. This question, following results were